Welcome back to the maths videos with ExamLearn. Hopefully you remember looking at displacement, velocity and acceleration. So we did them earlier when we were talking about differentiation. So displacement is basically distance, velocity is speed, and acceleration is still acceleration. And it kind of looks at real life problems of how these are related to each other, how you can deal with problems like trains traveling so fast, how long they're going to take, cars, people, etc. They're generally kind of real life problems to do with movement, okay? So do a quick recap and we'll look at how integration is helpful as well as differentiation to solve problems with these. Okay, so quickly, so let's say S is the symbol for displacement, hope you remember. So S is displacement. Now if we differentiate S with respect to T, so ds dt, if we differentiate it, that will give us V, but it'll give us velocity, okay? So this is really useful. So now if we differentiate this again, so if we get d squared s dt squared, okay, that'll give us, or sorry, you can also say that's dv dt. So if you differentiate this again, or if you differentiate this, you're either going to get d squared s dt squared or dv dt. Both of them are the same thing, and this is a, which is our acceleration. Ooh, no, acceleration. Yeah, that's the one. Okay, so hopefully you remember all that. If you have displacement, you can differentiate it to find velocity. You can differentiate that to find acceleration. And that's useful if you want to find the velocity, acceleration, displacement at any kind of time. You can just do that using calculus, okay? You don't have to get 3 different formulas. If you just get displacement, you can find the other formulas yourself. So let's draw this quickly. So this is the example we're going to be doing. So quickly, I'll just write this kind of thing up here. You see what I mean? So we have displacement, velocity, you can guess what the last one is acceleration. Okay, S, V, and A, they're the symbols for them. So we remember that, like we said up here, if you differentiate it, okay, you go from displacement to velocity. And again, if you differentiate it, so diff stands for differentiation, you get from velocity to acceleration. We also know that integration is the opposite of differentiation. So that means if you integrate something, so int stands for integrate, and integrate, you can go from acceleration back to velocity, and then from velocity back to displacement, okay? So this is going to be really useful in this question because they give us the acceleration first. We're going to have to work backwards to find the displacement and the velocity. If they give you the displacement first, you're going to have to use differentiation to find velocity and acceleration. So it really does depend, but being able to do either one is super useful because you can mix them, kind of, you can do anything. Yeah, so look at this question down here in the green. So it says there's a body moving and its acceleration is given by a is equal to 6t plus 1. So at any time t, the acceleration is going to be 6 multiplied by that time plus 1, and that'll give us its acceleration, okay? And it also gives us 2 points of info here. It says when t is equal to 0, so at the very start of when it starts moving, when time is 0, velocity is 2 meters per second. Okay, so it's moving at 2 meters per second, it's the speed, and the displacement, the distance, is 1 meter. Okay, and it's asking us to find the velocity and the displacement of the body or the object or whatever you want to call it. And also then the velocity of the body after 4 seconds. Okay, so we're going to do this using integration. So I'll go orange for it. Yeah, so I'm just going to write this out first. A is equal to 6t plus 1, okay? And if we want to find the velocity, we're going to have to integrate the acceleration. So that means I'm going to say V is equal to the integration of 6t plus 1, and it's going to be dt instead of dx because we're dealing with t here. So don't be so worried about that, you just have to write dt instead of dx. Okay, so again, if we integrate acceleration, we're going to get our velocity. So that's going to be 6t squared over 2 plus t plus c. Okay, so don't forget our constant of integration. So just to clean that up a little bit, that's going to be 3t squared plus t plus c. Okay, so we want to get rid of the c if we can. It's better if we find the whole answer instead of a plus c because that's an unknown. So we actually can with this example because it gives us t is equal to 0 and v is equal to 2. So that's a piece of info we can use. So I'll do that in bright blue. So it says the velocity is 2 meters per second after when the time is 0. So that means if we look at this here, so I'm going to say put the v in there. So we can say v is equal to 2 is equal to 3 by 0 squared plus 0 plus c. So that's the velocity here. If you put the time 0 into all these t's and then the velocity v into the v, you're going to find your expression here. They'll all cancel, and we're left with c is equal to 2. Okay, so if we want to write our answer for our velocity, then I'll do this in green, is going to be v is equal to 3t squared plus t plus 2. That's our answer for the velocity at any time t. Okay, so that's the first part done, well, the first part of the first part. Now we're going to have to find the displacement. Okay, so displacement I'll do in purple. So displacement, we're going to have to integrate the velocity. So if we go back up to our little picture here, if you have velocity and you integrate it, you're going to find the displacement. So that's what we're going to have to do. So I'm going to say then that s is equal to the integration of 3t squared plus t plus 2 dt. So again, this is the velocity. If we integrate it, we get the displacement. So that's going to be equal to 3t cubed over 3 plus t squared over 2 plus 2t and plus c. And again, we're going to do the same trick, so we're going to get rid of the c. So it says that the displacement is 1 meter when the t is 0, when time is 0. So we're going to do this in, we'll go red, why not? So displacement is equal to 1 when all the times here are equal to 0. So that means that's going to be 3 by 0 cubed over 3 plus 0 squared over 2 plus 2 multiplied by 0 plus c. So basically that c is equal to 1. That all good, yeah? Yes, we have c is equal to 1. So that means instead of this here, we can rewrite, I'll just erase that quickly, and we can write a 1. Purple. 3t cubed over 3 plus t squared over 2 plus 2t plus 1. That's the displacement at any time. Okay, and then the last bit is asking us to find the velocity of the body after 4 seconds. So what we're going to have to do then is we're going to sub 4 into our velocity expression here. So I'm actually just going to put a box around this t. So I just ran out of space, otherwise I'd write s is equal to this thing here. Anyway, the second part of the question is asking us for the velocity when time is 4 seconds. So I'm just going to have to erase this bit in the red here, and I'll do that there. Okay, so I've erased that. I'm just going to quickly go through this. So v when time is equal to 4. So we're just going to sub t is equal to 4 into wherever there's a t. It's going to be 3 by 4 squared plus 4 plus 2. And that's going to be equal to, and that's going to equal to 54 meters per second. Okay, so that's something you can just kind of stick into a calculator. Yeah, so hopefully that all made sense. So it's similar to the video we had when we were talking about differentiation, but now we can go both ways. If they give us displacement, we can differentiate and get velocity and acceleration. If they give us acceleration, we can integrate and get velocity and displacement. So hopefully that all made sense, and that's one of the uses of integration in kind of real life problems.